Hello everyone, this is the second part of the lesson Introduction to Trigonometry. As we agreed earlier that we are going to work with right triangles because we will be dealing with the lesson for grade 9 students. So the second part talks about the mission, which is to find values of trigonometric functions and to apply the trigonometric functions to solve right triangle problems. The first application that we are going to solve together talks about the plane, the earth plane. This is a real-life application to apply trigonometry. To avoid a steep descent, a plane flying at 30,000 feet starts its descent 130 miles away from the airport. For the angle of descent theta to be constant, at what angle should the plane descend? So guys, if you notice that I underlined the two numbers with the two units, feet and miles, these two numbers represent the 30,000 feet, which is the height or the altitude of the airplane, and the 130 miles represents how far away is the plane from the airport. So you notice guys that we have two different units, so there must be a conversion of units here, either from miles to feet or from feet to miles in order to be able to work with this problem. So here we have a demonstration of our problem. We have the airplane and the airport, the 130 miles, how far is the airplane from the airport, as well as the 30,000 feet that represents the altitude of the airplane. You notice here guys that theta is the angle of elevation that the airplane is going to make in order to do the descent into the airport. This angle of elevation is alternate interior with the angle that's inside the blue triangle formed, which is the right triangle. So first, we're going to do the conversion from miles to feet in order to be able to work with the numbers. So the conversion is that 130 miles is going to be equal to 130 times 5,280 feet, which is going to be equal to 686,400 feet. So now we have two numbers with two same units, and we are going to use either sine of theta or cosine of theta or tangent theta. Since the two numbers that we have on our figure represent the side opposite to theta as well as the side adjacent to theta, we're going to be using tangent theta, which is equal to 30,000, the opposite, over the adjacent, which is the converted number, not 130. We're going to be using the converted number of 130 miles, which is 686,400. And in order to find the angle, we use the calculator by doing a shift tangent on the calculator, which is equivalent to tangent power minus 1 of the 0.043 whatever. This is the fraction that we already got. And you're going to be getting 2.5 degrees approximately. That would be the angle of descent. Let's see another application. Here we have another problem where we have an observer that's 5.2 kilometers from a launch pad who observes a rocket ascending. Question A. At a particular time, the angle of elevation is 37 degrees. How high is the rocket? Question B. How far is the observer from the rocket? Question C. What will the angle of elevation be when the rocket reaches 30 kilometers? So guys, here we're going to do a simulation and we're going to form a right triangle where a person is looking at the rocket, and this simulation is going to be in the following manner. X represents how high is the rocket. Y represents how far away is the rocket from the person looking at it. 37 represents the degree that we already gave in the given. And 5.2 represents how far away is the person from the launch pad. So in order to answer question 1, which represents finding x, which is how high is the rocket, we are going to use tangent 37. Why? Because x represents the side opposite to 37 degrees and 5.2 represents the side adjacent to 37 degrees. Doing the calculations, cross multiply on the calculator, we're going to end up having x which is the height of the rocket, being equal to 3.92 kilometers. That's an approximate answer. In order to answer question B, that asks about y, which is how far away is the rocket from the person seeing it, we're going to use cosine of 37 degrees. Why did we use cosine? Because 5.2 represents the side adjacent to 37 degrees, and y represents the side which is the hypotenuse in our right triangle being formed in the simulation above. And doing the correct calculations by cross-multiplying and using the calculator, you end up having y being equal to 6.511 kilometers. That's an approximate answer too. In order to find the answer of question C, which is finding angle theta, if the height is 30 kilometers, so here 30 kilometers represents the side opposite to theta, and 5.2 represents the side adjacent to theta, and opposite over adjacent is, of course, tangent theta. So doing the approximate calculations on the calculator by doing the shift tangent, of course, or tangent power minus 1 of the value obtained, we get about 80.2 degrees. Let's see another question that talks about a ship. This ship sails 340 kilometers on a bearing of 75 degrees. The first question is, how far north of its original position is the ship? The second question is, how far east of its original position is the ship? So guys, here you should be aware of the north, the east, the south, and the west. You see at the bottom of my page here, I gave you the directions so that you'd be able to do the simulation of your right triangle. Let's see our simulation. So here is our ship. 340 is how far away is the ship from the launch, from the bearing, and 75 degrees is the angle that the ship was moving in. So X represents the north part, where Y represents the east part of the ship. So in order to answer question A, we're going to be using cosine of 75 in order to find X, since X is the side adjacent to 75 degrees, and 340 is the hypotenuse. Doing the correct calculations, I will leave that for you, my guides, so that you cross-multiply and you get the exact value or the approximate value of X on the calculator. In order to find the answer of question B, you're going to use sine of 75 because Y represents the side opposite to 75, and 340 represents the hypotenuse, of course, and we'll be using this sine of 75, and you end up doing cross multiplication in order to find the value of Y. Thank you guys for watching. Any questions, I'll be glad to help.